It should be recording now. Wait,
Okay.
do you see the recording icon on the corner of your screen?
Yes, sir, I do.
Yeah, it's recording.
All right, 12:01. We should have. Oh, here comes everybody.
It's 9:31 at my house.
Oh, that's true. 9:30 all start. All right, did someone say they wanted to show their presentation real quick before I start?
Yeah.
Okay, go for it. I love the enthusiasm.
Okay. Can you see? Yeah, okay. So it's kind of hard to see because I used weight string. But over here, I made a pendulum. And to
Oh
that,
yeah, it's you got to unblur your background.
Yeah, you turn your background off.
It's actually pretty cool looking. It looks like it's like an invisible thing that you're holding.
yeah. Oh, great. Where's the blur? Whoops. You know where that
I think
is?
it's video. Can you just hit the little like caret sign?
Oh, yeah. So, as you can see here, this is kind of attached to a string.
There we go.
It looks like it's invisible and it's just floating in the air.
Attached to the ceiling. So to that, I got like 3 different balls of different weights, and I made the periods for all 3 of them. And just for fun, I brought this.
Awesome.
Is that an ice cream cone?
Well, we're gonna do Teams Day, and you'll be very knowledgeable about what we're about to do on our teams.
I'm gonna drop them from the same distance, which is 10 inches. It should be, and I'll start with the lightest ball.
Oh, nice.
And I'm gonna take my stopwatch and start. Okay, so this period for the light bulb is 2.35 seconds. And the period for a heavier ball, or slightly heavier because this is the heaviest, would be, let's check again.
This is the same, right?
Yeah, approximately. Oh no, like
should be easily. Yeah. Does so everybody, does the weight of the bob matter?
But this took about 3 seconds, 2.89.
Okay, so you'll have some operator error because you're doing it on a squatch, right?
Yeah, and this one's the heaviest of all of them.
Okay.
So this one's probably gonna make a really big difference. Because that one was a ping pong ball and a foam ball.
Will it make a difference if it's heavier,
and this
Bob?
is like one of those rubber crunchy balls.
No. I know the answer. Do you want me to say the answer?
Yes.
Yeah.
So it'll just make the pendulum swing for a longer time and not make it go slower.
Yeah.
It'll
make a longer period. So this actually was faster than the others because it had a bit more weight, but not that much of a difference. It still traveled the same amount of.
I love how you did your scientific experiment. I love it.
And I'm wondering if an irregularity in the shape would really matter, but I don't think so.
Well, it does, because the only thing that actually matters in a pendulum. Does the weight of the bob matter your time period, guys?
Not really.
No, actually, and we're going to show you that mathematically, the weight of the bob should not, right? So that's going to be operator error. However, if the bob becomes bigger, it might shorten the length of the string artificially, right? Because now your weight
technically,
is a little
because this string is kind of light. When I used a foam ball, it wasn't that taut, but when I used a heavier ball, it pulled on string.
Awesome.
So
Did anybody else do something similar?
I did one on a double pendulum and a pendulum
Oh,
goes
that's awesome.
up and down instead of back
So
and
this one
forth.
took about 3.5 seconds for some reason.
Air resistance. It has to be air
So
resistant.
I would definitely say I would do like an average of 10 swings.
Yeah.
And then it's very difficult to like stop it correctly. And we're about to show that
Because
mathematically. And
humans aren't exactly that great.
I love it. I mean, you guys are fantastic scientists.
My sister made a
Fantastic.
video on this. I'm gonna share it if that's okay. I made a video, yeah. Let's see. How do you share your screen? There's literally a button that says share screen. Oh, okay. So I'm gonna share it right here. Oh, okay. Sorry about this.
Nope, you're fine.
Miss Kara,
Well,
Yes.
do you want me to get a headset from my mic?
great. What is that? Okay, there. This is the video she made. So she tried to make so yeah, I made a harmonic pendulum, but it kind of didn't work, but because I made it with 3 and they were unevenly spaced, but it still kind of worked.
Did you click on the, if there's sound on it, did you click
Oh
the button
gosh,
for it?
You have to share sound.
Okay. How do you share sound?
So exit the screen share.
Okay. Should I take it away? Yeah. Oh, share sound.
Just close it.
That he made out of 3 balls. Hopefully.
Never mind, we can hear it.
Alright. Okay. Yeah, you can see the pattern right there.
That's kind of cool.
That is very cool.
And then let's see when it's gonna stop. It's slowing down. As you can see, the one in the front is swinging slower than the one in the back because of the different string lengths.
And they're at different heights.
Yeah, I made this. I'm actually surprised that it worked. Okay,
Surprised they were.
what are you doing? And individual ones. They work well.
So let's try to start from a little higher point.
So just push it back and wait for it. And
I like your American flag stick.
more harmonic than the back one, probably because the length. I accidentally altered the lengths and I put them in different distances. Anyway, that's it. Bye.
Very good. I love it. Very good video. Here, I'll there we go. That should end it. Excellent. All right, so that's what we're going to be discussing today. We're going to be doing a little math.
Yay.
A little math.
I have
Yep,
something
we're
to
gonna
say
do a little
not
math.
related to pendulums, but it's kind of funny.
Yeah, so let me get my lecture and then you could be the first one to do your presentation. Does that sound good? Okay,
It's really quick, but okay.
let's see. Da-na-na-na-na-na-na.
Miss Tara, be sure not to use any copyrighted music in your presentations because it makes it harder to share on YouTube.
How many music this time? No music.
I don't get that.
Does anybody get it?
I get it.
No.
Is it sort of like you're
Scooby-Doo.
showing that math?
Sorry, what?
Oh my gosh.
So
That's
pretty
Scooby-Doo.
much, if you haven't seen by now, once you do physics, you're pretty much doing math.
Well, what show is that?
Scooby-Doo?
Yeah, I knew that.
Scooby-Doo.
So with this in mind, we shall begin our physics.
Psychics.
Okay, let's see. I'm gonna put this. There we go. All right, so we're doing harmonic motion. We had one little demonstration of a pendulum already. What I want you guys, I'm pretty much just going to start on what I want you guys to take away math-wise from this level. Okay, and it's going to be two basic equations. Okay, so we're going to do a swinging pendulum and an oscillating spring. Okay, and the reason why I'm showing these two equations is because look how similar they are. Okay, so what is T? Does anyone know what T is?
A period.
Yeah. So what's a period in this?
A symbol that closes a sentence.
It's
The amount of
the
time it takes for a whole pendulum to make one swing.
That's right. It's the one
the
second. It's the
average.
time it takes. Right. So generally we're going to do this in seconds. And it's going to be, it's got to go from one side to the other back. And that's a period. All right. So it's saying, well, the time it takes one swing is going to be 2 pi L over G. All right. So L is going to be the length of the string. And then G, what's G?
gravity.
Can we be more specific?
Gravitational pull. 9.8 meters
Gravitational
per
force.
second.
All right. We got a number. That's pretty specific. What was it? What was the number?
9.8 meters per second.
Okay, so what does that mean? 9.8 meters per second. Or you could say, let's
Force of gravity per second.
Miss Tara.
right. So so this is actually called the acceleration due to gravity. That's that number you guys are reciting. It's the 9.8. Yes.
So you know how I said it? So you know how you can have meters per second per second? Can you have meters per second per second per second or meters per second per second per second per second?
Well, let's talk about what that means, and then maybe you can answer the question. So what does
We also put meters
meters
per second squared.
okay, what does meter per second squared mean?
Meters per second per second.
Yeah.
What does that mean? What does that mean?
Well, it technically means, I think it means that, so the first per second means that that's how much force there is, and the second per second is the actual per second.
Ooh, that's a good guess. I like it. So this is what I think of when I think of 0.8 meters per second per second. I'm sure you guys will think of something different, but I think of a very fast fact. So why are space capsules? I'm hearing a reverb. I don't know if that's
Maybe it's Emma.
might have to. Yeah, it could be. When a space capsule comes down, the re-entry and it burns up, due to friction, it's accelerating. Like 9.8 meters per second is the force of gravity, but per second is the acceleration.
9.8 meters per second is basically the gravity, but how much acceleration is the second per second?
Every second it's accelerating at 9.8 meters per second. Okay. So here's a good example. So at the first second, right, you're at, of course, 0. The first second you're at 9.8, right? But then the second, you're at like 19.6 seconds.
Yeah.
And then the third second,
Like 28 something.
you're at like third, and the fourth second you're on 40, and so that's how the acceleration due to gravity works.
It
Right?
doubles.
So it keeps going until you hit what's called terminal velocity.
So which means that means it can't accelerate anymore.
That's right. terminal velocity is pretty much the end of it. But yes, it will keep on adding onto itself. All right. So when you throw a tennis ball into the air, the first second alone is just 9.8 meters per second. The second one, it's accelerating. It's adding more and more and more. And so when I think of, going faster and gravity and it keeps accelerating, you got meteors going at 72 kilometers a second. You have the space capsule here. It goes around, let's see,
Your Wi-Fi's bad.
24,000 miles per hour. Or
So
you could
basically,
say,
can you ask yourself this question? How many seconds does it take to for your object to travel down at 9.8 meters per second?
A long
Is it
time.
that's 1 second. Right? So the velocity for the capsule is 36,000 feet per second. Per second it's hitting. All right. So we grab, that's what we're putting in. We're putting meters per second per second. All right. Now, the same thing we're going to talk about, very, very similar, is instead of a pendulum and a string, you have a spring. Okay. Now, this is going to oscillate, right? Its period is going to oscillate up and down at 2 pi square root of m over k. Okay. So m, everyone knows m. What's m?
Mass.
mass?
Mass. This is the only equation that involves weight or mass.
Just
It's
a question for all of these: isn't it slowing down the more it swings?
Right, exactly. So it's going to have to do with a couple things, and you guys are going to calculate that.
On your pendulum lab,
There's an R for your A.
So notice, so I want you guys to really, really understand this concept. Does the weight of the bob matter in a swinging pendulum?
well, in specific
No.
cases,
For how long
because it
it'll
makes it
keep
go
swinging.
farther.
The answer's no.
Oh,
There is zero mass or weight involved in this equation. You could
And what does
literally
the M
have a
stand for?
15-pound bowling ball or a 5
oh wait,
pound.
there is a mass.
It does not matter how much the bob is weighing. Okay. What
Well, it
does
does matter for
matter?
how long it'll keep swinging, but not for helping to swing. How long.
Well, there's okay. So in a friction, I should say in frictionless, maybe I'll be specific. So we're not taking into account any type of friction. We're not getting into calculus yet. So in this equation, it does not matter how much this bob weighs. The only thing that matters in a swinging pendulum, as far as the time or the period goes, is the length of the string and what type of gravity it's under. Like it's going to be Earth, right? for our experiments.
Just
On
a
a
question.
oscillating spring, all of a sudden mass does matter quite a bit.
There's
Okay.
there's an R for your A.
An R for your A.
You said M over A, and there's an M over R.
I think it's a K.
Oh, all right. That's a K. That's like a lowercase.
Oh.
Okay. So what it's
Weird.
over is this is a spring constant. Okay. It's in Newton meters. Okay. So this involves, when we did Newton's last class, right? So that's going to involve some sort of a force when we talk about Newtons, right? We all have our little spring here. So we're gonna actually calculate the spring constant. You'll hear this in physics class as Hooke's law. Has anyone used Hooke's law before?
Is it the law of Hooks?
It's the
I
law.
don't.
of Hooke. It's the guy.
Oh.
Okay, so this will be Hooke's law. But the weight absolutely matters. The
Yes,
K,
Sarah.
a spring constant, all the spring constant means is that when
Is it like the
is
stiffness of the spring or something?
oh, hold on just 1 second. When there is no weight, maybe you said it. Say that one more time.
Is it like the stiffness of the spring or something?
Yes, it does have to do with that. Okay, I thought I heard you say that. Okay, so the spring, it's what we're gonna call the difference between the two. Okay, so it's when the spring is itself and then you put a weight on it, and it's called the displacement. So you're going to basically calculate the displacement of the two. That's going to be, so the spring constant, although it has the word constant on there, it's going to be different for every spring. So you always have to calculate a spring constant first to know how stiff essentially your spring is without a weight versus a weight. And it's the measurement length. So instead of doing this length of a string, this is going to involve length, the difference between the two. Okay. So these are the two equations. I would encourage everyone right now to write these two equations down. You will have them in our breakout rooms and you will have them in the Kahoot. Okay. Let me know when everybody's ready.
So breakout
So-
rooms.
If you go to engineering, if you go to medical school, I mean, these two equations are very common on most general physics
T
exams.
equals time, right?
T equals, we call it period,
Yeah.
but
yeah.
yes, it's going to be in seconds. The units will be in seconds, which is a time. So sometimes you can have a T sub P for pendulum or T sub, S for spring. You can kind of make that however you want if it helps you better. And it's really not, I put a T in the textbook. It's like a squiggly T like this. It's like it's not a straight across one. It's like a Greek letter T.
So the R is a K, right?
It is a lowercase k. Sorry.
Okay.
Maybe I can actually erase that. Well, I don't know how to erase right now. Only know how to write. Doesn't give me an eraser on this thing. Okay, so to figure out a k, okay, is Hooke's law. I'll give you that. The spring constant equation is going to be force equals k times x, where x is now the displacement length. Okay, so in order to find k, you would have to know the force, which is generally the mass of the object plus gravity. So we did that last class. We measured force by doing the kilograms times 9.8. In fact, I should be 9.81 to find your newtons. That's your force.
What does
Times.
the word displacement mean exactly?
Okay, so displacement is going to be, let's see if I can draw it on something else. Here we go. Displacement is going to be if you had a spring one way, and then you put a weight on it and it's stretched out. The difference between how it was originally versus stressed out, that is the length of the displacement.
Okay.
So we call that in the equation in the force equals the spring constant X, we call that X. Okay. So essentially you would have to have the weight in newtons in your force, and then the difference between the two, the displacement, and then you can find your spring constant.
Miss Tara.
Yeah. And once you find, hold on, once you find your spring constant, you can now find your oscillating period by putting the number for K here, and you're ready to go. Okay, so it's a little more involved than an oscillating spring because involving mass, right? Yes, what's your question?
So you know how you can, write equations F equals KX. Do you even have to have, if there's one letter next to another letter, it just means multiply.
That's right.
Do you even have, can you just write FKX without using an equal sign? I'm just wondering.
No, it's
Well,
meaning the
F
force.
equals K
That's
times
right.
X.
It has to, it's just like 1 + 1 = 2. We have to have the equals there. So K times X will equal the force. Now, if you want to find K, we can rearrange the equation, right? And now we can have force over X equals your spring constant. And when you have your spring constant, you can now plug it into this other equation. Okay. And this is what you guys will be doing in your breakout rooms. So make sure you have all these equations. Okay, we're moving on unless somebody says otherwise.
Let's not move on.
This is my
Say
this is why I
otherwise.
had the funny cartoon at the beginning. This is physics. It's
It's
really
like
math. It's a lot of math.
Remember the pendulum lab you sent?
Yes.
If there was no friction and no gravity, would it go forever?
Oh, what a great
Yes.
question. Yeah, I heard there's a really popular similar question on if you had a pendulum like on an elevator, inside an elevator, and you accelerated up, all of a sudden the forces cancel out, right? Like you're constantly accelerating.
You would need the world's tallest building.
Gravity doesn't really make it, but I must admit, you have to have that tension force, right?
Yeah,
The
just to
string to
make it
pull.
last a long time.
Yeah, within the lab I actually did that. And it just went away from where it was supposed to be and kept on going around and around.
Good. All right, so let's actually do
let
a
me
little.
go 300. Oh, okay.
You can say it. Go on.
Yeah, it didn't let me go 360 degrees if it was at Earth's gravity, but when I put no gravity, it kept on spinning no matter where I let go of, like unless it was under 90 degrees.
Awesome. Yep. And because it has to do, that's part of the equation. It's a big part of the equation, right? In fact, when you have gravity that's more or less, you can then predict the swing or the period of the pendulum because it's in the denominator, right? All right. Let's do an easy one. You have a length of 1 meter. Does everyone have their calculators?
Yeah.
First tell me the equation.
I
What's
don't.
the time equation?
E times L over G, or square root. T equals pi r square root L over G.
2 pi.
I forgot some things there.
Miss Tara.
All right.
Do I need a more complicated one, or is this one good?
I think you're fine as long as it has square root.
Okay.
2 pi
equals 2 pi square root L G.
Okay, fantastic. So let's make our prediction of one period of the swing. I will put this in. So we have 2 pi square root 1 over, and what's G, guys? What's the number?
9.8 meters per second squared.
And we'll even do one better, 9.81. So how many seconds should this oscillate? There and back. 2. Very good.
2
So our
pi,
prediction. So our prediction should. Our prediction should 2 seconds. All right. So we can put this in a. Let's see if I can. Hold on, just 1 second. Oh, does it not let me do it? It might take my. I bet Zoom did that.
What?
Let me see if it's taken out my links.
Miss Tara, did you say that the calculator had to have a square root button on it?
It does. That's in the equation.
No, because
okay. So here's our pendulum, and our length is 1. Okay. It doesn't really matter the mass, right, guys? We can make the mass however big we want it. How big do you want the mass? We got 0.1 to 1.5.
1.5 or sorry,
Okay.
0.5.
Oh, 0.5.
We'll just keep it
When you say
as the equation said.
5. All right, our gravity is going to be Earth. So something different. All right, we'll put in our period trace, our stopwatch. Okay, now there's going to be operator error here because I'm pressing a play button. I'm going to put it on slow, but essentially there and back should be 2 seconds. So does it matter? We didn't talk about this yet. You see these degrees in this like lovely little protractor up here?
Mhm.
What is the degrees called? Does anyone remember from the reading? What is that angle called? Ooh, it starts with an A.
Angle of
No,
It's an angle.
amplitude.
Amplitude.
Okay. So does it matter the amplitude? Is that in our equation?
It might not be in it, but we do need it.
no.
Yeah, kind of.
Yeah.
So my question is, if I swing it from up here versus down here, is the seconds going to change?
No.
No.
Yes, no, maybe so. I don't know.
No.
Well, let's see. All right, so let's swing it from 20 degrees. Okay. And I'm going to, again, kind of milliseconds difference here because operator error, and go. All right, so you guys tell me when to hit the stop button. The period is now
Stop.
traced.
No.
Nope, it's got to go back.
Okay, and
Stop.
Stop.
No.
Oh, we're so close.
You can actually move the stopwatch to be next to your play button.
Oh, thank you. Oh, okay. Okay, we're gonna start. So that was 20 degrees. All right, I'm gonna go way up here. Y'all want to go all the way up here?
90,
Yeah.
90, 90, 90.
Are we still thinking you want 9?
Yeah, 90.
Let's see. Do a
90.
weird number.
80.
Let's do 80. Okay. And are we still thinking the swing should take 2 seconds?
Yeah.
Maybe.
Yes.
Okay,
Yeah.
No.
I mean, no.
let's begin.
it's actually on slow mode.
Well, it's on the exact gravitational well, yeah, it is on slow. I did put it on slow. Okay, tell me
Okay,
when.
and
Oh, it's more. 221.
so
Told you it was more.
Slightly more. We'll have a little bit of.
But it's still 2 seconds. Yeah.
It's still about 2 seconds.
2.2 seconds.
Give me my old eyes on reaction time operator error.
I think the period measures itself. I don't think you need to stop.
You're right. I don't need to stop. You're right. Let's continue going. We'll start. I can just divide it by the number of swings. Is that what you mean?
No, the period calculates the time, the place that you'll let it go, and the place it'll come back.
Yes, you're right. It does.
You don't need to stop it for it.
You're right.
And I think it's gonna stop itself after.
South Africa?
No, I think it's gonna stop itself after.
No.
So around 2.
Yeah, it stopped itself. Yeah. Well, oh wait.
Well, I hit the button. Sorry, you can't see
Yeah.
it. But essentially, you could average this. So if we have operator error in a stopwatch, like you could do this 10 times, right? And then just divide by 10.
I
Right.
got 2 seconds.
You can get, okay. So you're a little faster than my old eyes. So essentially, you could do this
0.2.
average. Now, if you're going to add in, that will change things, right? We're going to have air resistance. You go through water, like let's say, let's see, Mr. Mike made the example of like fishing and putting a bob in water, right? When you water, it slowly goes down, right? We have water resistance. We're going to see tune mass dampers do somewhat of the same thing. If we're going to try to use something for resistance in here, friction.
Hey, Mom.
Yes.
I have a little picture example before we move on.
Okay. Does it mess up my screen sharing? You show it on yours.
It's digital. So I might
Okay.
have
Can
to
you show
share
it
it.
in a little bit?
Okay.
Okay. It's only because it takes forever for me to talk to my iPad again. It takes too long. Okay, so that's our swing. All right, so let's say if we use a different weird number.
I got 2
I
seconds as
don't know.
well.
Okay, so you guys are better than me. All right, so let's see. 5.29. What's our equation again, guys?
2
F equals
pi
kx.
square
F equals kx. I think.
L
Oh wait, no, I'm
over
sorry.
We don't need
L over
K.
G. L
L
over
over
L over
G.
G.
L over
Okay.
G.
So
L
let's
over
plug that in the
9.8
calculator.
S by S.
Okay, we have 5.29. Okay, so we don't have 1 anymore. So what did everybody get before I show you the answer?
I didn't. Wait, what was the problem again?
5 point, yeah, the same thing.
The length of the pendulum is making the most difference. So what's the length? The length was 5.29. So what should be our period? And
What was the problem again? I kind of got lost.
4 seconds at least.
length be 5.29. That's the problem.
4.61 seconds.
Bam. Yes. Each period should be 4.61 seconds. Okay. Is that what everyone else got?
I
And
didn't
the
do
only
the.
reason why I'm doing this is because you're going to have to do it on your own here in a second. So essentially, you're going to need to know this equation, and you put in the length of the string, and the weight doesn't make a difference. You just got to know the acceleration due to gravity. Okay. Super easy. Okay. Why care? Before breakout rooms, why do we care about pendulums? What are some of the things?
Stabilization.
Yeah, stabilization. They can help buildings not
Who
sway.
wants to talk about? That's right, 2 mass dampers. All right, so what do we have here? Does anyone know? This was in the reading, this picture right here.
Yeah.
What was that?
A tower or a skyscraper?
It's the Tower of Pisa.
No, what was this?
Oh.
It was. I think it was in Taiwan. I forgot.
No, they did.
That was that big tower.
Taipei
Yes.
101.
Taipei 101.
Yeah, Taipan.
That's right. So in general, in skyscrapers, when we don't want a lot of wind shaking them or earthquake, we start putting pendulums in them. And this is one that's awesome because you can actually go and view it. They have them on bridges, right? Even have them in space on the ISS. Everywhere, right? Let's see, roads, bridges, all sorts of stuff. These will help damper the sway of things, right? It'll take on the energy. Let's see. Okay. Oh, this one was pretty cool. This is called the Foucault pendulum. Yes, I know Lola knows about the Foucault.
I was going to
I
show
do.
that. I was gonna share an image of the National Science Museum.
Okay,
The big pendulum.
fantastic. So why don't you explain the Foucault pendulum?
Me?
Yeah.
I can't though.
What does it do? What's the main purpose?
It goes around.
It says that the Earth spins.
Right, somebody has their hand up. Are you going to say what the Foucault pendulum does?
Yeah, it says that it tells that the Earth rotates, except if you had one on the equator.
That's right.
Which
Yeah, you do need to get the north, right? But you can calculate the difference between. You guys, anybody in Houston been to the Houston
Yes,
Museum?
yes, many times.
Yes.
Okay,
I've
so we've
seen that
seen
pendulum.
this pendulum back and forth, and it forever swings because it's got a nice magnet at the very top.
Like forever?
Yeah.
Like nobody's gotta wind it or something?
No.
Is that a gyroscope?
But in general, yeah, if you string, it would not. However, this one here swings. Now the one in Houston is 60 feet long. So how long does it take for one period of the Houston Museum's fixed pendulum to swing there and back one time?
January 6th,
Can somebody tell me?
Hold on.
Is it like
Okay,
8 seconds?
Now it's in feet.
Is it? I think it's like 8 seconds.
How many feet are in a meter?
3,
15
0.2.
seconds.
3.1, I think.
15 seconds. 15.5.
What problem are we doing? I'm kind of confused.
What do you mean?
Okay, so you have how many meters are in 60 feet? Let's do that.
10.
You got to divide by 3.2, right? Somebody tell me the answer.
0.3125.
That's like 18 hours.
Okay, let's do some unit conversions. Or
No,
feet.
No, the highest. Hold on.
Feet, 1 meter.
Hours?
60
No,
divided by.
it's way more than 18 hours.
18.75 meters.
Aww.
Okay, so we have 18.75 meters, and we can plug that into our equation. 2 pi square root 18.75 meters over 9. What's the answer, guys?
18.75.
No, 75 is the length in meters.
No, I was asking if that was the right question, right number.
Yeah.
Okay,
What's
8.6 seconds.
Okay.
I'm really confused. Can somebody help me, please?
Yes, what you confused with?
You're just going kind of fast and I can't catch up.
Okay.
So
I
what
will let you write.
So wait, what was the problem?
So from the ceiling of this Foucault pendulum is 60 feet long in Houston, Texas, like in the museum. It's 60 feet long.
Okay.
Well, we converted feet to meters. Okay, because our acceleration due to gravity is in Newton meters. Okay.
Hey, let me.
So all we did is we said 60, there are 3.2 feet.
6, 8.
Okay, yeah, I got around.
5.
I think Houston, is 7 seconds. So I don't know if there's some friction involved there. But yeah, I got around. All right, so we
Wait.
just converted. Go on.
Isn't it like, is there 10 meters and 60 feet? I think.
Well, if you think the best way to think about it is a meter stick. There are around 3.2 feet in a meter stick.
Yeah, I'm just using
So if
3.
you have 60 feet, you just divide 60 by 3.2.
Oh.
And then you get how many meters you have. And then of course, once you have the length in meters, you can then plug it into your
18.75.
Yeah. That's what I got.
Hey,
that's right. So now you have perfect. So now you have the
Yay.
length meters of your pendulum string. Okay, now you can plug that into our time period equation, right? And you can say 18.75 divided by 9.81, which is
For that one, I got 8.690.
Okay, yeah, that's pretty close. Good job.
This is what I got. 1.91134148985.
Yep.
Let's say 1.9.
9. Okay, you're very close. So the Hughes Museum says 7. So I'm sure there's some sort of friction on that. But that's the Foucault pendulum. Oh yeah, you got.
I got 8.6865235336 and so on.
I love it. Excellent. Okay. So this one, of course, is measuring what, Lola? What is the Foucault pendulum doing?
Measuring time.
That's right. Of the rotation.
Oh,
Things
right.
abound in the
Whenever,
cycle.
since the world is spinning, it technically goes in like a circle, but actually it's staying still. And since we're spinning it. Yeah.
There you go. Awesome. So now when you go to the museum, you could just everybody, huh?
Hey, I know that guy.
All right. Yes. I actually got this from one of your in like 2nd grade, I think.
Oh yeah.
Oh.
I will
All
not
right.
forget
So
it.
this is something else that's really cool that involves a pendulum. Okay. So this guy, and I just botch his name. So I won't say it. You can read it.
Zane.
Thank you, Emma. The Leonardo, he was basically the Leonardo da Vinci of ancient China. He did everything. He was the astronomer. He was the physicist. He was the guy, right? He was the math. Well,
He was the guy.
invented a seismometer. What is a seismometer?
Doesn't it like predict what direction
Measure earthquakes?
coming from?
It measures earthquakes.
That's right. It measures earthquakes. So, a seismometer. He invented the first one. And basically it's this orb with 8 dragons all around it that have little balls in their mouths. And there's a pendulum in the center. And depending on which direction the earthquake is coming from, it's going to swing in the opposite direction and the ball will drop. So this is one of the first seismometers to tell him which direction an earthquake is happening in. So this is pretty cool of a pendulum, right? All right, other cool pendulums, right? So your car, right? Like a motorbike, things like that. They're called, anyone heard of car
That's an amazing
suspension?
drawing.
Yes.
A suspension of a vehicle, that word.
Yeah, they're
And you
vertical
guys have
pendulums.
to know about suspension. Anybody about a suspension?
Yeah, I know about
Like
coil springs.
bungee cord.
Wait.
Okay, so they're generally called like shock absorbers. So they involve a coil over something, right? So over
Sure.
this is going to involve the fluid like we were talking about before. So there's a coil over this that's hooked to, this would be hooked to your tire, right? And every time your tire hits a bump, it's going to damper it, right? This
I have a
is like a
spring.
tune mass. Right. So here's a coil over this, right? And there's fluid in here, or the damper fluid or oil. And this right here, this piston here has holes in it. So if it moves, the fluid can move through the hole, okay? And slowly, and it bends the bumps on the road, right? Now with fluid, what happens to fluid if it heats up? Does it get more viscous or less?
Or
Less.
Like if you fill up, does it get like more thinned out, or does it get thick?
Thick.
When you
Probably thick.
water is water, it doesn't get thick or thin.
No, oil.
It's oil. So
So it thins out. So when it starts to heat up, that material will thin out and it won't work as well. So if you hit a lot of bumps a lot of times, if you have shock absorbed fluid like this, they won't work as well, right? So then we'll have air suspension, and some cars have that as well. Okay, so
I'm going to say one thing. You're hilarious.
another example of why we would use tune mass dampers. Oh, who knows this guy? This is awesome.
Is that tall Indian guy?
It is literally the tallest statue in the world. Who knows this one?
The Buddha guy.
It is in India. Has anybody ever gone to it or
I've never been
seen
to
this
India, so no.
I've never left my country.
Okay, this is called, you guys should definitely write this down and YouTube this. It's beautiful. It's called the Statue of, okay? And to give you a
Statue
scale
of Unity.
of unity, that's right. To give you a,
Does it unite?
these are the people down here.
Does
That's
it live
his
up to
toe.
its name?
It, that's his toe. Okay, so it is gigantic.
Oh,
Here's a scale of the Statue of Liberty versus the Statue of, okay, it is gigantic. Okay, so in this, you can actually ride, there are 2 elevators. You can actually ride through the, and all the way, probably like to his chest cavity area. And there's a viewing area. If you have to go to
Can't go through
India
his head,
and want to go
apparently.
to these tallest in the world, that would be awesome. So you can ride an elevator all the way up. Now, will this be susceptible to wind and earthquakes?
Yes, maybe.
Yes, yes. So they not have pendulum inside. They've got 2. Each pendulum is 250 tons. Okay. And of course, will swing. They are so good. They will withstand a 6.5 on the Richter scale and about 110 mile per hour winds. So it's pretty good. So that's like hurricane-ish winds, right?
How long did it take to make this?
Due to physics, engineering, and 2 pendulums. Okay. What were we gonna say?
How long did it take to build this?
Oh, it took 40 months.
Only 40 months.
only.
That's it. Shouldn't it take like 20 years?
So if you look up, like if you do a little YouTube on the Statue of Unity and like
I looked it up just now on Wiki.
it will, there's whole videos on the construction, how they make it, the 2 mass
Oh,
dampers
wow.
swinging. You can go through, there's a whole, like underneath it is a whole museum area. It's pretty cool.
What if it fell?
Tallest statue in the world, of course, using pendulums.
All
right.
From falling.
All right, so let's begin our breakout rooms. All right, before we do, we're going to take a little trip. Okay, we're going to go to Peru. So we're all going to get in an airplane. All you lovely scientists.
Why not the magic school bus?
It's a longer trip. We could definitely do a school bus. It's going to take a little longer to get there. We're going to fly. Who remembers chemistry class what we talked about with Peru? Ooh. It involved Lola or Levi.
Oh.
You're doing bird. It involved RNA. Where's Levi? Because he answered this question originally in biochemistry.
Forgot I had my mic off the entire time.
Oh, yeah. Okay. So what do you remember what we talked about with birds and RNA?
Birds and RNA?
Yes.
Birds.
So there is a staple in Peru that is used and flown throughout the world for fertilizer. And it comes from
Bird poop.
That's right. Desiree said it. Too. Which is also
Guano.
which is also
Kind of cracking.
guano, right? So bird poop is called guano.
Yes.
And what part of it was named? Part of the RNA was named after guano. What is part of the R?
Guanine.
There you go.
Guanine.
There you go. This is our last trip to Peru. Well, this trip
Last
to Peru.
trip.
So this trip, we are not going to go on the coast with the bird. We're going to go to a very famous historical sanctuary called what?
Machu Picchu.
My grandfather's been there.
So we're gonna go, and there's your little daughter, and it's beautiful. Don't you guys want to visit? All right,
My
so
grandfather's been
we're
there.
here for something special. There is a secret treasure. They have figured it out. That's right.
Wait,
Everybody
are we
is
taller
right.
now?
Everybody's right there.
I know, but like since we're viewing from a distance, I think we got taller.
All right, and look, you guys have fantastic map skills and treasure finding skills, and you guys have officially found the treasure in Machu Picchu. Okay, there is one problem though. Okay, so you've found the gold treasure. Unfortunately, getting back is going to be very difficult. Okay, you need to reach a boat. Okay, the boat leaves at 3 o'clock. And getting back is going to be very hard because you cannot be on the ground. Okay. Unfortunately, you can only swing through trees. Okay, to get there. So your ship with all your gold, all your stuff needs to leave at 3. And you have to swing through the forest over like the Alligator River. Okay. So you cannot get on the ground. I need you in your breakout room. So depending on how many people are in your breakout room.
Taking a screenshot of this.
Yes, please everybody screenshot this. I did put it on a web. You can
I'll
screenshot it. Right?
I'll do it.
What movies did you take this stuff from? Pictures?
I made the slide and I can confirm that I didn't make it. I did not take it out of a movie.
Okay.
Really? The first image?
Oh, the first, yeah, no, that's from Indiana Jones.
That's what I figured.
Okay, so you're going to calculate the time it takes you to get all the way to the 3rd platform and you're going to have to multiply however many people are in your group because you need all your group to get over there. Plus the bag, whether someone's the gold or it swings by itself, it's up to you guys. Okay.
I mean, someone
mind the
carry
person in the back.
I want you to notice the units. Some is in meters, some is in inches, some is in feet. It all needs to be in meters. Okay. And you're going to calculate the time it's going to take. So you need to tell me at what time you need to leave the first platform in order to get to the last platform or the ship. Okay.
Oh.
So you need to give time for everybody to cross it. All right. Your next awesome adventure. Once you get to the ship, you're going to hang the gold onto a spring system on the ship.
Why?
I don't. The pirates of the ship decided that's where you have to hang the gold. Okay.
So why it's visible to all.
I've given you the displacement number. I've given you the equations. I've given you it's a 10-kilogram bag of gold. And I've given you all the things you're going to need to. Oh, wait. If you guys can erase what's written on there. Well, I wonder if I can. Everything. So you should screenshot this page as well. Everything to calculate.
There's still
Spring. So first you need to know your spring constant. You tell me at what period the gold is oscillating at. Okay. How many seconds
to record this?
That again?
Are we gonna record this? Cause what if it splits into 2 different rooms?
No, you can record in a breakout room. I've done it before.
Yeah, but there needs to be another recorder in the other room, right?
Well, okay, I know what you're saying. So that's why we're asking everybody to either write it down or screenshot this.
I
So
did.
when you go to,
Yeah.
you're right.
Okay.
I will have, when you guys leave, I will have a whiteboard up with this information on it to confer back, or I can keep this up. But yes, when you go to your breakout rooms, make sure you have all this information available to you. So you screenshot of this, or you can write down the numbers. But essentially your equations for telling me what is the oscillation of your bag of gold is going to involve these numbers and these equations. All right, so you have 2 missions. Let's see if I can, I do have to stop share. Did everybody get a screenshot or at least?
Yeah.
Okay.
Not yet.
Okay, good. One more.
You can just write the
Believable.
last numbers on my thing.
Oh, I kind of forgot them. Okay.
So this will be interesting to see what everybody got. Let's see what team wants to go first.
Me. Let's do our team first because our team is better.
Okay, fine. Sure.
Okay, you guys were the first to finish. Let's see if we get somewhat of the correct answer.
Oh wait, no, I got it, guys. Okay.
Bring up the photo.
Were you able to screenshot it?
Yeah.
Yes.
Just barely.
Yeah, it will take us 60.8 seconds to cross the whole thing.
Okay, how did you figure that out?
So we figured out the period of each of the vines. Then I just did the time, the period of the vines times 5 people for each one, and then added the answers up to get 60.8.
Okay, so what was the period of the first one? How many seconds there and back?
2.8.
Okay. And what about the second one?
Approximately 4.
They're on the screen. Can you just read them?
Well, it's a little messy. Oh yeah, there I see the typed. Okay, 5.6, is that correct?
5.28.
Okay. Awesome. So you added all those up and multiplied by 5. Is that what I'm hearing?
Yeah, because there's 5 people.
Okay, so what time do you have to leave the first platform? Yes, Griffin.
I was just thinking that you can let the second person go after the first person crosses the first vine, and when the first person crosses the second vine, then the second person can cross the first vine.
Yeah, you don't all, so the way they have it set up here, right, is sort of everybody gets on, if I'm thinking correctly, like you are, everybody just all piles onto the second one and then they all do the second one next.
Yeah, that's what I was thinking.
So you're saying as this one is swinging, the next one can also swing, correct?
Yes.
Yeah. That's awesome thinking, man. Yeah. So you want, well, we can time down. Griffin, what do you think? How fast do you think they could all swing across then?
Around maybe like 30 or 40 seconds.
Nice. Okay. That's much better. Yeah, because currently how it's up is they're all going to one platform and then they're all doing it again. I like it. Thinking. All right, what do we have for gold?
For the first question, what is your spring constant?
Okay, what is the spring constant?
5. We got 5.
Okay, how did you get 5?
We did F equals RX.
You mean KX?
KX, good goodness gracious.
Okay, but how did you get F?
We did you had an arrow connecting F to the weight. So we thought
Yeah.
it was just the weight, and we saw that the weight was 10 kilograms. At least I think so.
Well, that's very close. Yeah, the weight equals mass times the force of gravity.
Oh,
Be right back.
That's why you're so close to the answer.
is it like 5.13 or something?
No.
Well, oh, does somebody want to say?
Well,
Yeah.
excuse me.
4.9.
Say that again.
4.9.
Right, so it's 10 times 9.8. So when you multiply by 10, you're just moving the decimal point.
98. Right? Sorry. 0.98.
So now it's 8 as F divided by what? In your force equals kx.
F divided by X equals K.
Yes, that's what we did.
That's right. So you have 98 divided by what?
2.
Okay,
So
what's
that,
your answer?
yeah, 2.
What's your answer? It's not 5, but it's close to 50. So we're just moved that other step, right?
49.
Yeah, 49. Yeah. So now this will be interesting because you're going to see where the square root is going to come into play when you miss a decimal like that. Okay, so with your original answer, what is the seconds? We have 8.8 seconds, right?
Yes. 88. Yeah.
Okay, because in your square root, you had, how was that set up? Mass over K. What was mass?
10.
A 10.
Yeah, 10 kilograms.
And so you just had a 5 instead of a 50, right?
Yeah.
Yeah.
But it's square rooted and it's in the denominator. So you can still be pretty close. So you're not far off by 8.8 seconds. In fact, you're off by 1 second.
Mm.
All right. So that was pretty good. Pretty good. I think the takeaway to that is a force of something, right?
Wait, how many
Involves
seconds should it be?
like your Oh, say that again.
How many seconds should it be?
It should be 9.8, but it should be 10 over 49, or you could round to 50. It's up to you guys. So you can plug that in and you can get around that amount. But because that number was in the denominator and it was the square root of the denominator, it only was a second off. So good job. I am very proud. And you guys finished this in like 10 minutes. So awesome. And I love the thinking about how the people can swing and cut your time in half for sure. I think if it was a race, you would race to this first for sure. All right.
When did it really start it?
Next
Okay.
people. All right. Next team. What did the next team get?
Yes.
Did we do it? Yeah. All right. Let's see what you guys got.
Okay. So we got an approximate period for this one of 3 seconds. This one
Okay.
the second one of 4 seconds, and the last one of 6 seconds.
Love
And
it.
we converted it to 7 meters, 4 meters, and 2 meters. Well, it was already
Excellent.
2 meters.
I like you just kind of rounded. I like it.
We added all
Maybe
those up
easy
and we
number.
got 13 seconds, and then we multiplied that by 5. We got 65 seconds, which was 1 minute and 5 seconds.
Okay.
So we just did 1 and 1/12 of a minute. And then yeah, that's about it.
Lovely.
There's another page, the whole thing about the spring. Yeah. And I just realized that it'd actually take time for the spring to end. That's why there's a period. So I think we actually have to add that time too.
Okay, so explain.
So the period's actually kind of wrong, kind of. So yeah, over here the spring constant was 49.
Yep.
The period we actually got 384. No.
So
That
what
was-
did you get for M? So you have square root of m over k? What's that?
So m was 10 and k was 98.
That's right.
Oh,
Well,
okay, so I did this wrong.
k was 49. 49. 98 was the force that you used to get.
I'm sorry, 49. Yeah, we did do 49, so it got 2.8384 for the period.
Okay, I'm getting a different number than 2.8. Could we recalculate that? Because you do have all your numbers correct.
So here, okay, I'm gonna repeat it. It's 2 pi times the square root of 10 over 49.
Yes.
Yeah, and it says 2.8384.
Make sure that your m over k, both of those is under, sometimes you need them in parentheses under the square root. You make sure they're both under the square root.
They are. Okay, let me see. Parentheses.
Unless I got it wrong, can anybody else calculate that? Just to
Yeah,
make sure.
I'll give it a shot.
Okay,
So
I'll re-put it in.
The square root of
Why does this
10
one
over
have
49.
pi?
I will put it in. Let's see.
Where?
I got
Oh,
2.83.
here. Okay.
I
Hang
don't
on.
know.
Pi times
Okay,
10.
square root of 10 over 49.
Oh, you are right.
Yeah.
Desiree,
Yeah.
why is your
Look at me. Look. I love it. So the answer is actually 2.838 seconds.
Because it's 2.83, we just added 3 more seconds to it, which means we need to leave at about I mean, we started our whole journey, I guess, or whatever it is, at 2:58 and 52 seconds. 55. No, because we got the extra vote. Yeah, so 52 seconds. But then again, humans, they take too long. Usually.
Humans.
Yes.
I love it.
I don't actually know how long this dock is.
Hello, humans.
That's true. The dock was kind of negligible, wasn't it?
And it doesn't really matter what time they leave it, does it? Like, unless they arrive exactly when the boat leaves.
Yeah,
if that was a question, yeah, it would make sense.
The boat if they get there early, it doesn't matter.
It doesn't matter, you're right.
Yeah, so
That's only a good life lesson. You should always arrive early.
Mm-hmm.
Yeah.
Excellent. Okay, so now you can actually see the difference in value. So sorry, I don't know why I originally got 9.8. I have to go through my anyways.
I forgot to do the square root, and I think you did 10 over 98.
I think you're right. You're right.
If you did 10 over 49, and then without the square root, if you multiplied that by 2 pi, you'd get approximately 9.8.
Yeah. Yep. Just put it in the calculator wrong. Happens all the time. Awesome. I'm very proud of you guys. So
your presentation is next?
I actually think it's a tie on this game because I sort of like the ingenuity of the faster time on the first team. And then the second team, I mean, pretty much got the gold locked down on the correct second. So I think it's sort of a tie on both teams. You guys did awesome. Okay. So now it's any presentations anybody wants to do. You're
I have
more than
one.
welcome to play the Kahoot. Okay, go for it.
Okay. Can you see my screen?
Mm-hmm.
Yes.
Okay.
Did you share the sound?
It's okay. Oh shoot, it needs to be unmuted. Tell me if you can hear it. Hey guys.
Yes.
Okay. Today we're doing two pendulums. A bouncing pendulum that goes up and down instead of side to side, and a double pendulum. I don't really say much. It's just I do that, and also my dog was in my lap the whole time.
I like it. He makes a cameo every time.
Mm.
I like the bouncing one. I haven't seen the rubber band one yet.
And when you just let it go like that, it starts going crazy. And then by the end of the video, it's watching. That's basically my presentation.
So that's sort of like the spring oscillations, right?
Yay, thank you.
It's kind of combined. That more the boingy effect. I think you can make a new formula for that.
Yeah.
Hey,
It's going crazy.
Hey Lola, did you do Foodie Friends?
No.
All right. Anybody else want to share
I have
anything they
something that's
did?
not related to pendulums. It's just kind of funny.
Okay.
So I was like, with my mouth, and then was like, wait, why isn't my mouth moving? Yeah,
The mouse wasn't working because they had that thing on it.
Ah, because it was sliding on the paper instead of the mouse. It's okay. We all do stuff like that. Right. Anyone else? Or is everyone ready to play Kahoot?
Ready to play Kahoot.
Okay. Let's see if I can set it up.
Do you do a different version today?
A different version.
Oh,
Before
do we
I
have
do
coding
that-
today?
Do we have coding today?
Up to you guys. All right. I'm gonna do classic mode. Unless somebody says otherwise.
Wait, I have a suggestion. We should make this the most chaotic
Classic.
Kahoot ever.
Can we do the tower
Otherwise.
mode, please?
Wait, hold on.
Otherwise.
I would probably cry if it
So
was chaotic.
what I'm
Oh.
thinking is,
I
what if we did the let me see what modes I can put it on. The falling tower would be pretty
Classic,
cool.
classic, classic, do classic, do classic.
Power is the worst.
Classic.
Classic, 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 classic.
Classic.
The mode.
You should do classic.
Tower mode.
anything but classic.
Now it's gonna be iffy and it's telling me
Finicky.
I knew I should get out of that.
I'm getting
classic.
Anything but
I'm getting
classic
more.
or team classic.
Can you try tower
There's a
mode?
fly in my wall. Now I
Tower
can't
mode.
drink it.
Tower mode.
Don't fly. I can't drink my water now
water?
because there's a fly in my water. Now I can't drink my water.
Tower mode.
How did I get in? What?
It was thirsty.
Exactly.
All right, I gotta get out of this. Now it's being weird. Shouldn't have
It's
gotten out of
currently
it.
making the world record for breathing underwater right now.
Who?
It's
fly?
making the fly in my water.
Yeah.
There we go. Now it's happy.
Okay.
Happening.
Okay, so we could do it's Robot Run, Lost Pyramid.
Classic.
Classic.
But
Classic.
also-
Classic.
Classic, 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 classic,
Wow, it's exploding.
All right,
Classic.
I'm gonna pick three.
Hello?
Classic.
I heard classic.
Yay.
Anything but classic.
Anything
What?
but classic.
Classic.
Anything but classic.
Classic.
Classic. Close it. Go.
Anything but classic.
Anything but classic.
Okay, Miles, I'm gonna have to mute you. I can't leave it. All right. All
I'm
right.
sorry. I'm really sorry.
It's okay. It was just so loud on my end. I couldn't hear anybody. All right. Now everybody's silent. My goodness.
We're
You told
preparing.
us to be quiet.
We're preparing.
Hiya, physics.
All right, we should have 12. I think there's 12 kids in the class.
I really am sorry.
It's not a problem.
Oh.
E.
One more person.
EA. It's in the game.
All right. Is here. Speak
Who
now.
the hecky is pink?
We shall begin.
It's the emoji, isn't it, Emma?
The band. The singer.
Yeah.
Yeah.
Oh my God. 3, 2, 1. What subject did Galileo's father want him to study?
Oh, this is from the reading.
So it's that
Mhm.
priesthood. It's that
Priesthood.
priesthood. He wanted him to go be a monk.
I think it was like two
I don't think
things.
that was correct.
No, it was one.
I knew it. It was not. I think it was art or something.
Levi,
Of
you
course.
E.
Yeah, medicine. Yeah. What language? Study.
Chinese,
You
Japanese.
learn Chinese.
Oh, it was Chinese and Japanese because that's where he
It was
lived.
Spanish and French.
Uh-oh, that is gone.
Latin
Who
and
put
Greek.
Chinese and Japanese? Someone was convinced.
What did Galileo's father do for a living?
Oh, what?
Writer,
Okay.
musician,
He was,
painter, and sculptor.
He was
I think he was a writer.
a musician.
I have no idea.
I'm getting off the podium for that.
Oh, I was right.
Dun, 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 dun.
Bruce.
Oh yeah.
Oh,
Wow.
Ah.
Oh no.
Dear Lord.
please.
Yeah.
Oh.
God, what was that?
It's
I just
glitched
got it
on your
wrong.
screen, Miss Sarah.
Do air molecules have any effect on swimming pendulums?
Oh, it looks like
Okay.
Miss Tara's screen froze.
Yes?
Miss Sarah froze.
Your
Where's Miss
screen is
Tara?
froze.
That's
Like-
the question.
Her entire thing froze.
Yeah.
Oh.
Maybe.
Oh,
Okay.
there we go.
Yay.
Yeah.
Okay.
Yay.
Who's higher physics?
May.
Oh, it froze again.
No. What's the quote called? Oh yes, okay.
The movement of the
No,
stars.
you're
No.
frozen.
The movement of
Yay.
the stars.
Yeah.
Okay. Hang on. Miss Sarah, you're frozen again.
Yeah, she knows.
Okay.
If you increase the length on the string, okay. I'm here to get longer.
The
It
pendulum
gets
is tied
tied
in
in a
knot.
knot, y'all.
Yeah, everyone's still talking.
Yay!
Oh.
I'm
Oh.
winning.
Wrong. I'm in
Uh,
10th place.
Okay.
In
Boy.
fourth place. Wait a minute. I'm only 290
place
points
right now.
behind my brother.
Hold on. It kicked me out. I'm gonna get back on
What?
see the main thing.
Wait,
You're
what?
back.
Oh.
Kick
Yeah,
you
it
out?
kicked me out. I like got out of the whole meeting.
Yeah.
Do we have to
That
restart?
means that Emma was the host for a short period of time.
Hold on.
Emma realized
Share my
it.
Had the power.
Let's continue, everyone.
Okay, pendulum swinging back and forth is an example of.
Node.
Did we even learn this?
A pulse.
I think it's periodic or harmonic motion.
25% chance.
Yay.
Yippee! Reigning 9th place right now. I mean, just the queen.
How does a pendulum have the most? Oh, okay. 1, 2, 3, and 5.
Looking for 5.
Nope. It was just the first
Ah,
one.
dang it.
That's 3.
Yes, I'm third.
Emma, are you Vikram?
No.
Nothing. Nothing.
Nothing.
Who's sorry?
Yes, I'm second.
Decreasing gravity means the period of the pendulum is what? Okay.
No notification given.
So somebody asked this in class.
Good for me.
Yeah, what do you think it'll do?
Oh, goodness. Oh. Increase.
You know, the only way you can get to higher places is if people get it
I will
wrong.
say,
You
one of
can't
the
get ahead of them in any other way.
Yeah, I misclicked. Well, okay, I'm still up there.
Will a swinging pendulum not swing forever? I don't understand what that question. Yeah.
Because we're not. I mean,
I mean,
technically,
is
there's
yellow
two correct
wrong?
answers to this.
I just
I
Wow,
don't know
who's
if yellow's
pink?
really wrong.
Who's
That's
pink?
Lola. That's
What do you
Lola.
think is pink, Emma?
Okay,
What is a format? Oh, great. Okay, I
I'm in your
remember.
walls.
Oh.
Wait, this
Walls.
seems kind
Wanted
of
to let you
wrong.
know. Yeah,
What's
I'm back.
L by J?
Everything seems wrong.
What's
Dun,
L by
Alright,
J?
dun, 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 dun,
Oh, okay.
dun,
Yay.
dun, dun, dun.
that
Guys.
was square root, wasn't it?
Guys, hear me out.
What could you use?
No stock
for?
image of a third person is complete without the E equals MC squared
Oh,
equation
no, it was
somewhere.
above.
I didn't look at the
All
green. I
above.
didn't look at the green
Yeah.
answer.
No.
I didn't look at the green answer.
I just picked red.
No.
Double points. Okay.
Double points. Math.
Period. Okay, G. What?
Oh boy. Oh boy. Period of
Um,
oscillation.
Hey, boy.
We calculated 1 meter length in class.
Well, the gravitation. Okay, 9.8 and 1.2. The mass doesn't matter, does it?
No, it's not in the equation.
I didn't get an answer that's close to it. Oh no. Oh no.
Are we allowed to use a calculator?
Yeah. Oh yeah.
I
Okay,
didn't-
good.
Oh no.
Yeah.
Oh no.
Emma.
Oh no.
Please.
Oh zoinks.
Here.
Emma, are you okay?
I don't think she is.
No.
ನಾನು 1.22 పెడితే ఇస్తాను కదా నేను పెడతాను.
Is there another double point problem?
No.
Double point problem. Let me get those double points, boy.
What's so sad about it?
Apparently, my calculator does not agree with these equations, so I can't use it.
Okay, I'll just tell you the answer. It's 2.2. 2.2. It's a blue one.
I was one
Thank
off.
goodness.
That's what I
was
chose. That's
one
what I chose.
off.
I chose that
Everyone
one.
plot 2 point. Yay!
Man,
That's 1966
No.
points.
how dare you?
It's funny. Spring constant is represented in Newton.
Newton meter.
Oh, great. It's
I
Newton
think
meter.
my reaction timing is
Okay.
a little too reactive.
Wait, I have an idea. What if we all pin Emma?
Nobody got it.
Did no one get that right?
I don't think
No.
anyone did.
A spring oscillating would fall into the field of physics. Vibration waves.
Mechanics, I guess.
No. Oscillate.
Yay.
I am 1 point behind Alita 1.
Me so.
Huh. 1. In the physics, up and down motion of the spring is called what?
A
Oscillation.
colonoscopy. A colonoscopy.
I've had one of those before.
What?
Waggles? Is that even
You didn't need to say that.
Waggle?
You didn't need to say that.
Yes, second.
Which one?
You didn't need to share that with the group, Miles.
Ooh.
Murphy's Law.
Beginning.
Law. Hooke's Law.
Murphy's Law. I know that show.
It's Hooke's Law.
Back in ninth.
I really just wanted
Reactive spring force is a function of displacement. What physics variable represents the slope?
Variable.
No.
Okay. Okay.
This is a complicated. So you got to know the units of the spring constant. It's what?
Oh no, I'm just doing n by m.
You did.
Oh no! Oh no!
I think
Force over. You calculated in class. Force
Oh, no.
over displacement.
Oh.
Yeah. I was right. Wrong than correct.
All right, so that's something to know. Your spring constant is going to be that type of the slope of that line.
How come I'm still second?
What's the speed of a harmonic spring oscillator? Okay, not 1 by G, 2 pi, 2 pi. Oh wait, what? Why are two? Oh, TP.
Wait.
Okay. Wait, it's TS actually. No, wait, TP. Oh, great. I don't remember. Yay. TP? No.
TP.
The spring oscillator is not an example of simple harmonic motion. Yes, it is. False.
Yes, it is.
Yay.
Yay.
Yes, I'm first.
Okay, this is Williams.
Everything in my room. I just now
Yeah.
realized what the question
Yay.
was. I got it wrong because I'm
What's
dumb.
a tuning mass stamper? Oh, great.
It's a source of energy. It's a wrecking ball.
It looks kind of
There
cool
was
how
another
the
very
pendulum is made.
specific and
Wrecking
Then
ball,
I-
y'all. Wrecking ball.
that was it.
Where are used tuning mass dampers? Okay, in bridges,
Where
in
are
spacecraft,
you?
in power
Where are
generation
you?
lines,
That's on
in,
my
It's
in
we're
ice
just in
sculptures.
Is it multi-select?
No.
Where are
Yeah.
used?
Wait,
in
Okay.
fifth
All
place.
of
Feel like
I'm on the podium.
in spacecraft. They don't use their. That's not fair.
Leon
75%
Volcon.
chance everyone will get it right. Okay.
Leon Volcon.
Foucault. Which
Is rotating or revolving? Is there really a difference?
Leon Volcon.
Yeah, revolving is just going around.
I
Yeah,
The Earth revolves around the sun.
I'm still
Oh,
first.
study that. Okay, Leon. Oh, I know. Sorry.
Boyle.
It was Copernicus.
No, it was Galileo.
It was Gallup. Ayo.
In fact, I actually shouldn't say the answer.
Ayo.
Copernicus.
Oh.
Everyone got the
Down
right.
Ayo.
Okay, in physics taste.
Owing the bell.
Ring the
of
bell
any
is
class.
fast.
Ah,
That's what I
yes. Wouldn't that be interesting?
No.
No.
Ah,
I just got
Combo
passed.
dare
breaker
you.
4 players dropped their answer.
Oh,
double
double
points.
Okay. A pendulum on different. Wait, different. True.
I can't believe
Yay. I just passed Alexis.
Yay.
Dun, 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 dun. Oh, come on.
Yeah.
That was a really.
If the physics club wanted to create a pendulum, then could
Create a new prototype.
Yeah, well, I guess they have to. Mhm.
This next one's the last question.
last question.
Boring. What is inertia?
That is what we learned today.
Tendency for.
It means no entry.
The next.
Got killed.
Wow.
Means no end
That
point.
gift. So why didn't I flinch?
Neil deGrasse Tyson. It's Neil deGrasse Tyson.
I'm rocking 10th place.
Hurrah.
Aim for
I
the
was in
podium
first
next
for
time.
so long
I'm
there,
always
and then
Can we do another one with the tower version? That was more funner.
Things happening.
I don't know.
Who's
Nickname is
BM a
taking
guy?
first and third.
Sorry.
I got
Good
third.
job, guys.
Einstein glasses.
I got third.
Okay.
Yay.
Who got third? Raise your hand.
Can we play the tower
Who was
version?
first?
No.
Yeah.
Please,
Please.
no.
Never.
Please.
If anyone wants to, I can like host it or something.
Okay. Do it.
Well,
like this Harvard.
we're already two class.
Oh, Emma, you good?
All right. So maybe I'll make the next game. The issue with that one is I have to figure out how to do that. Teams to do that, don't you?
Just a question. You sent a link for more Kahoot thingies in the Google Classroom, but you can only start it at a specific time. So how do you know if all the people?
Hey,
Oh, Miss Tara disconnected.
He left.
Oh no!
Griffin,
Griffin,
make me the host, make me the host, make me the host.
No,
Dang
he's
it.
back.
Okay, here I am. I'm back.
Okay.
I was the host.
Okay, sorry. I had Kahoots. What was the question?
So how can everyone start at the same time? Because you need to click the start button when you start it. So you need to know if all the people who want to do it. Like, do you need to make a
That's
specific
right.
team?
Yeah. That link was just if you want to practice on your own. Like,
Oh, okay.
Go.
So was it like a practice link?
yeah, you can back and practice this if you would like. Yeah.
Oh, okay.
Or you can do a different game. You know, basically it's for a solo thing.
You can do it with others.
So next time into the tower game, we can do that. By the last Kahoot question, it on inertia. And it's going to be on Easter. So there's some cool experiments involving eggs. Hey,
Oh, yeah, that trick.
Egg drop.
Yeah, next week.
Yeah, so we're gonna do an egg drop. This is gonna involve inertia, so it's more heavy trick with the tablecloth where you pull it super fast and none of the dishes or anything fall.
Yeah. Are we actually supposed to do that?
Yeah.
Yeah.
So that's inertia, right? Like objects at rest are gonna want to stay at rest, right?
We're allowed to use plastic, right?
But you can do it since it's Easter time, you guys might be dying eggs or something. You can use eggs. And I put a video on there
Betty eggs.
having like an egg with a board and doing the same and see how fast you can pull it. So the egg just drops down, right?
The one in the cup in the water?
That's right. Yeah.
One. Oh. That's
so
cool.
you could do that. But there's tons of inertia stuff you guys can do. So next week is super easy. I think the reading is super quick. I think it's only a couple pages. So it's
and there aren't actually that many videos next week. So
yeah, I think next week is a really, really easy class. So if you guys want to do some videos for that, that'd be good. And besides that, I think we're done, guys.
So now that we're done, do any of you?
Or not?
So now that we're done, do any of you want to play Minecraft?
Sure. I think you can be doing computer class, right?
Yeah, we'll
Yeah,
be
what
doing
about
coding.
the coding class?
Wait, we're
Okay,
gonna move on to coding after this?
Yeah.
Okay. Cool. No.
What time is coding supposed to be, by the way?
Coding is immediately after physics.
Yeah.
Okay.
It doesn't have a set time.
Yeah. And it's really computer principles. AP.
Okay, which section are we on again?
okay.
All right, so anybody who doesn't want to do or is not in our class, you can go ahead and go in the computer AP class. Emma is coming up. I think you guys, man, it's been a couple weeks, right?
How do you do it? Like,
So are you in the Google Classroom?
yeah. Which one?
For the computer class, Google Classroom?
I think so.
Okay, cool. So they're gonna name a lesson on. You go to that lesson, and you will
Is it the electronics 2023 one?
Yep, I believe so. Let me see.
So if any of y'all live here in Texas, my group is gonna have a spring fling this Friday. So it's basically just like a dance and a hangout. So y'all can come if y'all want, but the tickets are almost sold out. So
I know Emma's jealous.
That's okay, Emma. I won't be going.
No, it's not okay.
You're gonna be back. You're gonna be back for Thanksgiving. We're gonna have you for Thanksgiving at our house. Oh my God, what is that face?
hey, we might have another one next year.
Okay, so Emma, do you need to come here or you have all the stuff?
Like, how do we? What are we supposed